Okay, guys. So, find the coordinates of the turning points. Now, first of all, what shape of graph is it? Is it N shape or U shape? It's an N shape. What is an N shape graph? It's a minus x squared. The x squared controls the shape. If it was plus x squared, it'd be U shaped. You know it's N shaped. Now, if you aren't sure about this and you have it in the exam itself, like if it was N shaped or U shaped, what you could always do is you could always just type it into the calculator, okay? Now, the problem sometimes being is you don't really know where to start and end. So what I'd always recommend about starting and ending is that you just maybe go 10 points either side of the x-axis. So start at minus 10, finish at plus 10. And what you have there is you get a wide range of points. And all these points, now you're not going to draw at minus 10 plus 100, minus 164. That's way too large. So you're going to go down until they're more reasonable values to draw. Okay? Now, if I was to draw these out, and what I'm going to do here, just going to use the next diagram here. On part B, as it turns out, is a sketch the graph anyway. But you could always do a quick sketch yourself. So what I'm going to do is, that's the positive x-axis, so what it's going to be is 0, 1, 2, 3, 4, 5, and 6. Okay? And, go. So, as it turns out, we actually need 0 minus 4, because 0 minus 4 is the 0 minus 4 is the first point that would be in that range. So we can call that only goes as high as 6, because the points in your calculator are 0 minus 4. They're 1 1, 2 4, 3 5, 4 4, 5 1, 6 minus 4. If you're wondering where I'm getting them from, they're all there in a list. So you can see all those points are the ones I just wrote down a second ago. Yes, Sean? Did you enter in properly? Did you start at a number smaller than 0? Therefore 0 will be included. So you have to go smaller than 0 to get 0 included in your number list. Pick like minus 5 or something like that. Yeah, and you'll get it. Okay, so I have these numbers here. Now, it's quite obvious to see that if that's 1, minus 1, minus 2, minus 3, minus 4. You can draw this out now, quite easy. 0 minus 4, 0 across, minus 4 down. Done. 1, 1. So that'll be 1, 2, 3, 4, 5, and 6. 1, 1 being there. 2, 4 being up here. 3, 5 here. 4, 4 there. And 6 minus 4 down here. Oh, sorry, I did do 5, 1 and didn't do 5, 1. Alright, so guys, we can see there it's an N-shaped curve. So you would have figured out whether it's N-shaped or U-shaped. If it's an N-shaped, does it have a maximum or a minimum? It's a maximum, because you're climbing on top of a hill as opposed to being on the bottom of a valley. So when you find that you're going up the hill, it's a maximum. But on a U-shaped graph, however, it would be a minimum because you're at the bottom of a hill. So you start off there and you go on your way down. That's a minimum when you're at the bottom of the hill. Okay? So you know automatically straight away, you know your turning point. Your turning point is 3, 5. How would you do that using differentiation only though? So here's how you do it. At any maximum point, what's the slope? Or a minimum point, what's the slope? 0. In differentiation, how would you get the slope formula? First derivative is your slope. So your slope equals the first derivative. What's the first derivative of minus x squared? Minus 2x. 6x? 6. 4 turns to 0. Now, I just told you that your slope equals 0. So what happens next? Put it equal to 0 minus 2 equals minus 6. 2x equals 6. I multiply both sides by minus 1. X equals 3. As predicted, the maximum point is occurring at 3. However, how would you show how you got the value of 5? How would you do that? You sub it back into the original. Please remember, f of x represents the y value. And the y value we're looking for is when x equals 3. So it's going to be minus 3 squared plus 6 times 3 minus 4. And then once you do that, you're going to find out that it's equal to 5. So your value in question would be 35, and you also have a diagram to back you up. Even if you weren't asked for the diagram, you could always do a quick sketch of the diagram in the corner and figure it out that way if you're looking for attempt marks. Full marks would go for the derivative and figuring out that way. Alright, next one, question 8. First of all, U-shaped or N-shaped? So, the profit of the oil, I haven't done this one before, have I? Okay, so, look, everybody looking at this? I'm not looking at anything else. Okay, so, it's an N-shaped curve, okay? And it gives you the profit function, where P is the daily profit in euro and X is the number of barrels of oil traded a day. Complete the following table. I'd once again go straight back here. And instead of P, what would I use instead of P? P is f of x, and I'm going to do 96x minus 0.03 x squared. Is it a good idea to start with a negative number? And if not, why not? X represents the number of barrels. Can you have minus 10 barrels? No. So you can have no barrels, and it's going up in 500, isn't it? So maybe a good, the end is 2,500, because you can see that's the last value. But the gaps are going up in 500, so that means my step should be 500. And long and behold, I get my list of values for each one. Okay, so what I do is I take down these values. So 66,000. What's the next one then? 76,500. 72,000 and 52,500. Okay, it's not as perfect as my last one. Remember the last one I drew was very much like that's at the same level as that one, that's at the same level as that one, therefore the top of it is dead center. This time around it's not perfect, so you can't be guaranteed about where exactly the top is. Okay, so it says draw the grapher's traders function on the axis below. So draw out the numbers basically. So what we're going to get is 500 and what's it, 40,500 around there. 1,000 is going to be worth 66,000, which is going to be around here. And then 1,500 is going to be worth 76,500. That's around 77,000, so around here. And then 2,000 is going to be worth, how much is 2,000 worth again? 72,000. 72,000 is just about there. And then finally 2,500 is 52,500, which is dead center there. If you're just wondering, guys, just do a quick line across every time and you can see roughly what values I'm hitting every time. I think that one might be 76,500, yeah. So you can see exactly how high your graph is, each one, okay? Now, link it up just best you can. That's sort of a bit of an error there, that's even more so, but that's as good as I'm going to get because of using this. Now, ask me to answer some questions. The question wants to be asked is, use your graph to estimate when the daily profit when it's 1,750 barrels. Okay. Now, the great thing about this is you can sort of you can figure that out using your calculator, can't you? Or you could figure it out by subbing it in to the formula. So you can find out an exact amount, but what I really want you to do is use your graph. So, how do you start this one off, Jordan? So 1750 on the x-axis, because that's the number of barrels. 1750 on the x-axis. Go to 1750. It's halfway between 1,500 and 2,000. Then you bring your line directly across. If you have that much barrels, you're going to have roughly, what's it, about 76,000 euro profit? Around that, around 76,000 there. Okay. The number of barrels traded when the daily profit is 60,000. Why is there two answers and not one? But to make 60,000 euro, the problem is it happens twice. happens twice, doesn't it? So it happens once here, and then a second time around there. So you have to give a good estimate on both numbers. That's 750 in the middle. What's halfway between 1,000 and 750? 875. This one here that's 2250. Halfway between 2250 and 2500? 2375. Or some people say, look, it's actually a lot closer to. You can decide. I reckon it's around 2375. Some people might round off to 2400. Yeah, you can have a completely different answer, but once it's in the ballpark, you generally get full marks. Okay, guys. Now that's really easy. That's a lot of marks for just knowing how to draw a graph. Now, where the higher marks come in is find the maximum profit and sorry, what is it? D part 2, is it? I obviously missed D part 1 somewhere. Where's D part 1? There it is there. Use calculus to find the number of barrels of oil traded that will earn the maximum daily profit. Where do you think the maximum occurs, guys? What be a ballpark range for your maximum? Somewhere in here, yeah? So you're expecting the X value somewhere between 1,500 and let's say 1,750, somewhere in that ballpark region. I haven't got a clue right now. I said this earlier, and this is the second time I'm saying this today. What can you be guaranteed about the maximum? Slope is 0. And once again, like all other questions, what is if your function or your y value is this, what is the slope? How do you find the slope? First derivative is your slope. So you can call it the PDX. The reason we call it the PDX is the letter on the left is P, and it's explained using X. If that was S and T on the other side, it'd be ds dt. Okay, depends. The letter on its own, the letter on the left always stays on the top. The letter that you explain it in is on the bottom. So that's your slope, and your slope will equal 96. Then x squared is what, guys, when you differentiate it? 2x. Then 2x times minus 0.03 minus 0.06 x equals 0. Okay, after that, guys, figure out what x is, yeah? So 0.06x equals 96, and then divide it by 0.06, and what you get? No, actually, sorry, yeah. If I do it this way, Sean, it can be done like that, and then multiply both sides by -1, and I get the same answer. Okay, go and get 1600. 1600 was within the region I was expecting. Remember I showed you the diagram earlier? It's within that, the upper part is around 1600. Okay? The next question is how much oil did you make? How much profit did you make when you're at 1600? So what you do is you get your profit. Your profit is 96 by x multiplied by 0.03 x squared. Your x value is you're selling 1600 barrels to achieve maximum profit. Therefore, to achieve maximum profit, it's 96 times 1600 minus 0.03 times 1600 squared. Put all that into the calculator, and you find out that it's 76,800. Finally, the trader will not make a profit if he trades more than K barrels of oil a day. Calculate the value of K. Well, do you remember we made that diagram earlier? Yeah? What happens if we keep going on? What happens if we went to 3,000, 3,500, 4,000? What would happen then? Is it on its way up or its way down? It's on its way down. If we get lucky and we find out where it hits 0, then we realize the point at which we start making no profit. So you can go back here, and you just go a bit higher. Go to maybe even 5,000. Go up in 500s. Now look what happens. When you're on 500 barrels, you're on 40,000 euro profit. When you're on 1,000 barrels, you're on 66,000. 1,500 barrels, 76,000. And then all of a sudden you start to drop. So obviously your production costs are going through the roof and dragging down your profit. So then you keep going downwards. Look what happens there. It was a positive 18,000, and then it became a negative 31,000. That means in between 3,000 and 3,500, you cross the x-axis. So your answer has to be somewhere located in there. So how do we actually go about doing this? Well, you make no profit. You will not make a profit when your profit is 0. Therefore, your formula for profit must equal 0. Okay, you look at both of them and you say, okay, what do they have in common? What do both numbers have in common here? What does yellow have in common with green? They have x in common, so you can take x out of them. And what happens then, Sean? X into 96 minus 0.03x. Either x equals 0. What does x equals 0 mean in the context of this question? If you make no barrels, you make no profit. That makes sense, doesn't it? If you sell nothing, you make nothing. Okay? And then the other one's going to be 96 minus 0.03x equals 0. Move it over to the other side, we get 96 equals 0.03x. I'd like to spin this around. And then I'm going to divide by 0.03. What's 96 divided by 0.03? 3,200. And that was precisely what we predicted earlier. Somewhere between 3,000 and 3,500. So we know we're right before we even leave. Question 9 is, Amanda buys a new car for 25,000 euro. She knows that the value of the car depreciates by a fixed percentage each year. She draws the graph below to represent the value of her car for the next 6 years. Okay? Using Amanda's graph to estimate the length of time it will take for her car to depreciate from 15,000 to 10,000. What do you think of that one, guys? 15,000 to 10,000. 15,000 is at, you reckon 2.25 years? How did I do? Or 2.25, how do I get that? And there's 4 boxes for 1 year. Does everybody see that? 4 boxes for 1 year, which means that 1 box will be equal to, divide both sides by 4, it'd be equal to 0.25 of a year. So that means 2.25 for that one there. What about the next one? 10,000 euro? And straight down, is that 4 years? Or just after it, 4.1ish? Not even, I'll just go to 4, yeah, just go 4. Take them away from each other and what you get? About 1.75 years. Okay, that's one and take away the other one. Right, that's easy money right there in that first question. Now, done. Continue Amanda's graph to find the approximate value of her car after 7.5 years. So I have to continue this graph. So what I'm doing is, you can see that it's going down a bit steeper, then it starts to level out a bit. So you just have to make a rough guess. You won't do this, and you sure won't do that. Because this first option is it just plummets down in value. The second one is that it regains its value. Now, that rarely happens, okay? So, what we get is this, guys. It continues on. Now, we defined out 7.5 years. So, where's 7.5 years? Hits there, goes across. How much is the word after 7.5 years? About 5,000. 5.1. I had 4.8 in my solutions. You can actually be slightly off. It depends on what way you drew it. Okay. So I'll go for 5.1 this time. What is the name? What name is given to the type of curve she drew below? So guys, these are what are called exponential graphs. Exponential graphs is when it either curves up, or I'll just draw 2 axes here for a second. It's either when it curves up like that, or an exponential graph can be when it also curves down like that. They're exponential graphs. Quadratic graphs are where it goes up and down. Is that right? Exponential is when it just keeps going up or keeps going down. And it curves, and then quadratic graphs are U-shape or N-shape. What's the name for the green line here? Linear. Okay? 3 different types on your course. So we should know that this is called an exponential function. like that. Exponential. Okay? And that's A part 3 done. Now we're on to part B. On the day that Amanda bought her car, Carl also bought a new car. His car cost €22,500. Amanda's car will travel 15 kilometers on a litre of fuel. Carl's car will travel 10 kilometers on a litre of fuel. How many kilometers will the cars have to travel until the cost price of the car plus the cost price of the fuel are equal for the two cars? Assume that the fuel cost is €1.50 litre over the period. What we find is that his car cost 22,500, but her car cost €25,000 new, didn't it? So Amanda's is €25,000 new, but Cottle's is 22,500. The only time they cost the same amount is when is when Cottle spends 2,500 more euro on fuel. So we have to find out when Cottle spends 2,500 euro, not 2,500 euro in total. She has to spend 2,500 euro more than Cottle. Okay? So what I decided to do was, on a really basic level, I decided to figure out how much litres how far each car can get on a certain amount of petrol. Okay? So what I did was I drew myself a little table to figure out what exactly is going on with the two cars. The first car represents Amanda in kilometers. The second one represents Cottle's car going in kilometers. The top part represents how much litres of fuel I'm using. 1 litre, 2 litre, 3 litre, 4 litre, 5 litres. Okay? Now what I'm going to find out is that Amanda's car goes 15 kilometers an hour. 15 kilometers on 1 litre. Cottle only goes 10. That goes to 30. Goes 30 on 2 litres, while Cottle's only goes 20. And then 3 litres in, I find like a lowest common multiple. So I now have something I can compare them to. If they travel the same distance, if they travel 30 kilometers, what happens is Cottle uses 1 more litre of petrol than Amanda does. Would you agree with that? If both cars travel 30 kilometers, Cottle's going to spend 1 litre more on petrol. You agreed with that? So here's what I did then. Every 30 kilometers, Cottle uses 1 litre extra of petrol. Okay? And because of that 1 litre of petrol, how much does that 1 litre of petrol actually cost them? That costs them €1.50. Okay? So every 30 kilometers, he gets €1.50. He spends €1.50 extra. So what I'm going to do is, we were told earlier that Amanda has to make up €2,500, doesn't she? And what I did was I divided 2,500 by €1.50. How many times do they have to do this before you make all your money back? Is basically what I'm trying to figure out. So do 2,500 divided by €1.50. And as it turns out, you have to do this another 1,667 times. That means they have to travel 30 kilometers another 1,667 times before you make your money back. So then I multiply that by 30, and I figure out that my answer is actually they're going to travel 50,000 kilometers to make that happen. Okay, so that is a particularly random question, and I'd say very few people, and even a lot of honors level students wouldn't get that out.